Okay, so we're going to prove the logical equivalence that P and Q or R is equivalent to P and Q or P and R. So this is what's known as the distributive law for propositions. Okay, so what we need to do first is have columns for all these propositions. So P, Q, R. And then we got to find all the possible combinations between these three. So for P, that'll be true, 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 false, 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 false. And then for Q, true, true, false, false, true, true, false, false. And then for R, true, false, true, false, true, false, true, false. Okay, so now I want to figure out what this is going to produce, what truth table this is going to produce. So I'm going to first find Q or R. So Q or R. So T or T is T. This will be, so if I have at least one T, then I'm good. So this one has at least one T. This one has at least one T. This one doesn't. So I know this will be false. This one has at least one T, one T, and then false. Okay. So now I'm going to do this whole part. It's going to be P and Q or R. Okay. So now I'm going to look at column P and column Q or R, and there's an and, so both of them need to be true in order for this column, for this part in this column to be true. So true, true, true. I know this is false because it has a false here, and the rest of them are false because all these P's are false, right? So the rest of them are false. Okay, so now I'm going to look at this side, look at this part, and then this entire part. So P and Q. So I'm going to look at column P and column Q. So true, true. So the first two are true, but I can see that there's a false for the rest of them, right? Because the rest of them have at least one false. So false, 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 false. Okay, so now P and R. So P and R, so true, uh, false, true, and then the rest of them I can see have a false, right? Because there's a false here, so this one will be false. And the rest of these are false for P, so the rest of these are false. Okay, so now I'm going to look at P and Q or P and R. So we're going to look at these two columns here. So remember for OR, let me make that OR a little bit nicer. For OR, we only need one true in order for the entire thing to be true. So this is true, true, true. But look at that. The rest of them are false, right? Because both of them are false, right? And look at what we have. We have that P and Q or R is true, 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 and then the rest are false. And P and Q or P and R is true, 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 and the rest are false. So this tells us that these two statements, right, are logically equivalent to each other, which is what we wanted to show. So this implies that P and Q or R is logically equivalent to P and Q or P and R. And that is the proof.